is day 2 of choosing a factoring method, so we're going to make sure we go through those rules. We're going to start by first taking out the greatest common factor. Always looking for greatest common factor, which would be 3 in this case, and an x. 3x times x squared gives me 3x cubed. 3x times 2x gives me the 6x squared. And 3x times 2 gives me the 6x. Now you may try to factor this because you see this is a trinomial here, and you'll put an x and an x here and a 2 and a 1. Those are only factors. When you check these, you get a 2x and a 1x, and there's no way to get a 2x here. So we'd have to say that we're finished at this point. This next example, we're going to take out the greatest common factor. The greatest common factor is 5. They both share an x cubed in common. I'm left with then 5x cubed times x gives me 5x to the 4th, and 5x cubed times 4 gives me 20x cubed. This is also finished because there is nothing I can do with this inside parentheses. My next example, I have greatest common factor. There is no number that they share in common, but they do all share an xy in common. So xy times 2x squared y gives me the 2x cubed y squared, plus xy times 4, I need a 4, I need an additional x, and the y is taken care of by out front, plus xy times, I don't need anything additional, so I'll put a 1 just to hold its place. This, again, is not factorable because there's nothing I can do to break this up into 2 sets of parentheses. Moving on to the next type of problem, I'm looking again and going through the steps of greatest common factor. On this one, there is no greatest common factor, so I'm going to, since it's a trinomial, break it up into x times x. Thinking of factors of 12 as 1 and 12 and 2 and 6 and 3 and 4, I've got to create a sum of 7, so I'm going to choose 3 and 4. This is 3x and 4x, which does give me a 7x. The next problem here I have a no greatest common factor again. If I can break this down into y times y, the factors of 9 are 1 and 9 and 3 and 3. 3 and 3 are the ones I need because I want a positive 6. This gives me a 3y and a 3y, which is a positive 6. And I can write this as a quantity squared, 3y quantity squared. My next problem, looking for a greatest common factor. There is no greatest common factor. The nice thing about this one is I notice that this is 2x times 2x, so this is a square term, and this is 5 times 5, which very well could simplify my factoring and not have to try so many things. I'm going to try 2x times 2x, and I'm going to try 5 times 5, and good for me that I get 10x and 10x, which gives me a 20. I need to make them both negative, so I get a negative 20. I'll write this as a quantity squared as well. My next problem, I have no greatest common factor, but when I look at this again, I have a squared term and a squared term. So I'm definitely going to try the 2a times the 2a. And notice I have a b squared here, so I need to say this is 9b and a 9b. This gives me 18ab and 18ab. I need a negative 36, so I just need a negative on both of those. That does give me negative 36. And so I can write 2a minus 9b quantity squared. My next problem here I have is only 2 terms. And so I've got to think, is it a difference of squares? These are both squared terms. I can say this is z times z, and this 5 times 5 gives me 25. I'm trying to create that 0 term, so I need a minus and a plus on the inside. That gives me negative 5 and a positive 5, so that gives me the 0 term. My next problem, I want to say this is another difference of squares. And so 10 times 10 is 100, and then t times t gives me t squared. It is a difference of squares, so I need a 0 term on the inside. This gives me a positive, or a negative 10t, and this gives me the positive 10t, which makes me have a 0 term.